Hi everybody, here's a movie for hypothesis testing for means. We're going to do one of these at a time so you can practice them nicely. And I'm doing a real simple-minded one right now. Let's look at the story. A random sample of 100 observations from a population with standard deviation of 60 yielded a sample mean of 110. Test the claim that the mean is more than 100. Let alpha equal 0.05. So the key to these is reading. So what do we know? We know that the random sample of 100 observations means n is of 100. Okay? Standard deviation of 60 is sigma equal to 60. The sample mean of 110 is x bar equal to 110. Now the key sentence in here is the one that starts out with test the claim. As soon as you see that, you know that that's a hypothesis testing question. And then the rest of it gives you one of the hypotheses, very often the H1. So in this case, the mean is more than 100. So you've got, it's always going to ask a question about a mean. In this case, the secret words are more than, which means greater than. So in this particular case, it means H1 is going to have a greater than as its symbol. Finally, the last sentence gives you your alpha level, or your level of risk. So now we're ready to start our four-step procedure. And we have HO of mu less than or equal to 100 versus mu greater than 100. We got the mu greater than 100 from the second to last sentence. And we know that the HO has to be its exact opposite, so it gives you HO of mu less than or equal to 100. The test statistic is the formula here, x bar minus mu sub 0 over sigma over the square root of n. So you've got your numbers from your story, so you put in 110 minus 100 over 60 over the square root of 100. That gives me 10 in the roof over 6 in the basement, which gives me 1.67. So now it's time for the rejection region. Since we have a greater than, we start out with 0.5 referring to half of the normal curve minus alpha. That's our level of risk. So we have 0.5 minus 0.05, and that gives me 0.4500. That's a probability. So I need to use that in my normal table, and I'm going to look in the middle where the probabilities live, and I'm going to look for the closest value to 0.4500. And that's going to be, that's one of those funny ones. It's at a halfway point. So there's a 44.95 and a 45.05. So you're going to take the 44.95, and the z that's attached to that is 1.6 from the row and 0.04 from the column, and if you add them together, you get 1.64. You have to have an if-then statement. So your if-then is going to be if z star is greater than the 1.64, then we reject HO. Okay, is 1.67 greater than 1.64? Yes. Therefore, we reject HO.